Good morning, guys, or afternoon, depending on when you're watching this. We have a really short little lecture today. So if you will grab your notes packet and we'll go over the next section. So we've covered the structure of the membrane. We've talked about that by lecture and also in class. And now it's time to talk about the function of the membrane, which really we've already addressed a bit. This diagram will be on the next 2 pages. And so we're going to use this diagram to continue to talk about the function of the membrane. So there is a term connected to the membrane, and it is called selective permeability. This term, or this kind of vocab word or phrase, basically tells us that the membrane chooses. It is selective as to what it allows in or out of the cell. And so we have this membrane. It serves as a boundary. It helps to keep the external and internal world of the cell separate. And as substances move back and forth across the membrane, we see that things can enter the cell and things can exit the cell. If the cell let everything in, that would not be good. If the cell membrane blocked everything from coming in, that would not be good. So having a membrane that is selectively permeable, choosing what comes in and out of the cell, helps to keep the cell alive. So let's address the first question in your notes. What things move in easily? Now, you did a POGIL, and most of you hated the POGIL, and I get it. It was a little bit different. POGILs in general are designed to help you improve your skills at analyzing a model, skills related to prediction, and interpretation. And so a lot of you struggled for, quote, the correct answer, and it frustrated you. I will address the POGIL either in class, if you are in person on Friday, or a little bit through the end of this video if you're watching this at home. The big takeaways from the POGIL are what moves easily across the membrane, and then what things don't move easily. So possibly after this lecture, your POGIL might make even more sense, although technically they're designed to be done on the front end of content so that you're really analyzing models as opposed to just writing down facts that you know. But maybe it might help after you know sort of the content. So what comes in easily? Well, there are 2 characteristics or qualities of a substance that determine whether or not it's going to cross the membrane. Its size and its polarity. And so small things move through the membrane really, really easily. And so over here on this picture, you can see oxygen and CO2. They are very, very small molecules, 2 atoms, 3 atoms large, or I shouldn't say large, 2 to 3 atoms in their structure. Those are going to be small and cross through the membrane pretty easily. We start talking about other small molecules that are polar. These were nonpolar, but small polar molecules will move through relatively easily. But look, the bigger you get, large molecules do not pass through the membrane easily. And then we'll address the charged molecules in a second. What else moves very easily? The nonpolar molecules move through the membrane easily. Even if they're large, if they are nonpolar, they will cruise through the membrane. The reason for this is all of the fats, the lipids in the tails, in the cholesterol of the membrane. We talked in class about how the membrane is mostly lipid based. And remember the likes like. Remember, I told you that really confusing thing that you'll see again in chemistry, and like dissolves like. So the membrane is primarily nonpolar, and therefore it invites its nonpolar friends to cross. So if you are small, you're coming through. Small, nonpolar, you're coming through really easy. If you're small and polar, you will come through with a little bit more resistance, but your size still lets you kind of squeeze in between these phospholipids. If you're big and polar, you're bounced out. It's really difficult to cross. If you're big and non-polar, hydrophobic, because you're non-polar, you will cruise on through. So great examples of things that move easily: oxygen, CO2, and water, which on your POGL, hopefully you said were elements that are necessary to keep the cell alive. Water, we're going to come back to. Water moves in, it's polar, and so it's small, so it moves, but it's polar, and so it moves a little bit slow. So there are channels, protein channels called aquaporins that help to account for the fact that our cells need to regulate water pretty regularly. And these channels will allow the water to move in much faster than they would normally cruise through on their own. So water gets a little bit of help in the form of these special aquaporin channels so that it can move through faster than it would at its natural pace. So recapping here on this slide, what moves through the membrane easily? Small molecules that are nonpolar move the best. Oxygen and CO2 are nonpolar and small. If you are small and polar, like water, you will move through at a slightly slower rate. If you are nonpolar and maybe big, you get to come on through. If you're big and polar, you're out. It's really difficult to move you through the membrane. Ions as well. So these are completely charged molecules. Those are really challenging to move through the membrane. Next question in your notes: what must be transported in? Well, we do have to get large molecules in, like glucose. So there are special proteins that help bring in glucose molecules. Polar molecules have to come in as well. And so if they're small enough, like water, they might diffuse on their own. If they're larger, they're going to need some assistance. And then ions being fully charged, they cannot enter the membrane. They have to come in through protein channels. So really, the first question of what moves in easily is more about what moves in on its own. If you're small and nonpolar, you're coming in on your own. If you're nonpolar in general, you're coming in on your own. But if you are big, if you are polar, if you are an ion, you need help. And that's the you must be transported in. So let's take a look at the POGL really quickly and try to connect this back. So here is our POGL. In the first model, you were given type 1, type 2, type 3, and type 4 molecules. So right now in this moment, if you are a B student, you have not had a ton of discussion over this POGL. We ran out of time Thursday in class. So you should get your POGL model, pause the video, go get your POGL model, and check it as we kind of go through it. So here are the 4 types of molecules. And in this chart, ions, you're given a few different. Here's potassium, sodium, calcium, and chloride. It's asking you, what's the charge? So in this blank box, you would say that these are ions. So you would write ions. They are small. Over here in molecule type 2, here's glucose. It tells you, for perspective, that glucose is polar and it's really, really big. That helps you make some determinations over here. So type 3 molecules, water and urea. Water, we know, is polar. So you should have written polar right here. And based on the size, if this is large, these polar molecules are much smaller. So small should be written in this other blank box. Type 4 molecules are nonpolar and they are also small. Based on the fact that you called these small, these would also be. So recapping, our type 1 molecules here are ions that are small. Our type 2 molecules are large polar molecules. Our type 3 are small polar molecules, and our type 4 are small nonpolar molecules. So these first couple of questions ask you what needs to come in, what needs to go out. So for number 1, I would expect that based on your understanding, you would say substances that need to come in are things like glucose for energy, water, and oxygen. Right? So those are probably the things that you would think of in this moment, and those are correct. In this one, number 2, it says, well, what needs to leave? So think about the things that are waste products that need to get out of the cell. So things like CO2 And maybe you said urea because you're thinking urea, urine. I know we purge that from our system. Urea is a heavy nitrogen component, NH2, and it's the way that our body does get rid of nitrogen in the form of sweat and urine. So for number 2, what goes out? Water. You might say water sometimes goes out of a cell, and that is true. You might say urea, and you might say CO2. We've already addressed number 3 by looking at the fill-ins here on the chart. So now we're on to Model 2, and Model 2 asks you to take the information from Model 1 and apply it. So in 4, you're asked to identify these structures. So this right here was probably easy. That's a phospholipid. This right here, charged particle, that's an ion. This you should have identified as glucose, or a type 2 molecule, just by looking at the shape up here. Here is glucose, which is a type 2 molecule. This one that looks like a little fan blade, this is the structure, if we look back up here, of urea. So you could identify this as a type 3 molecule, or you could have called it urea. And then last but not least, these little things that look like paper clips, that is actually CO2, carbon, 2 oxygens on the end. So that is our type 4. So in A, it says identify these shapes: phospholipid, ion, glucose, urea, CO2. B asks you to label each diagram with the type that we see. So that would be coming up here and identifying this. Here's a bunch of ions: type 1, type 2, type 3 molecules, and type 4. And again, if you're going, where do you get these? From the types of molecules back up here in Model 1. Ions are type 1, large polars like glucose are type 2, urea, which is a small polar, is a type 3, and carbon dioxide is a small nonpolar. So that's what you did in B. And then for 5, it says circle as shaded with a highlighter where you think that the molecules originated in these models. And so to me, I think about where would ions be? Where would glucose be? Is it on the outside of the cell trying to get in? So you would have circled or highlighted this side for ions. They are outside and they want to cross in. Over here, again, glucose is outside. That's from our digestion that wants to eventually be transported in. Down here for urea, that's a waste product. So that's accumulating inside. So you would have circled or highlighted inside and it wants to move out. And then same thing for CO2. That's a waste product of cell respiration. And so it would be here inside the cell trying to get out. In number 6, it asks you to kind of look at what molecules appear to be blocked by the membrane, what passes freely, what passes with difficulty, etc. So up here, just by looking at the picture, the ions have not moved, which tells us ions do not pass across the membrane very easily. We now know that from our lecture. Ions have to have proteins embedded for them to move. No proteins here in this lipid bilayer. Glucose moves, but it moves very slowly because it's small and polar. Down here, we see that urea moves a little bit faster, but because it's polar, it's not super, super fast. And then here we see our small, nonpolar, perfect molecules for movement that have gone across the membrane and have kind of equaled themselves out. Remember, a bunch of them started here, and then half of them have moved across because they move easily. So if we look at this last question right here with the key next to it, the majority of the membrane is made up of nonpolar hydrocarbon chains. Use the diagram in table 1 to explain the permeability, the movement of things across the membrane for each type. So this is where you should have said type 1 ions do not move across the membrane. Type 2 move very, very slowly because they are large. Type 3 move a little bit faster because they are smaller. Type 4 move the best and the fastest because they have the two characteristics, small and nonpolar. And so they can scoot across the membrane pretty easily. Now let's look at this last page here. Number 13 says aquaporins. What do you think that they transport? Well, you know now from the lecture that they transport water, but hopefully you saw aqua as a prefix and you thought water. So these are the special proteins that transport water. Down here in number 14, it asks you to categorize these. So are these molecules, based on what you can see, type 1, type 2, type 3, or type 4? Nitrogen gas, these are small, nonpolar. So these are type 4 molecules. Hydronium, they're small, but look at that charge. That's an ion. So these are a type 1. This one right here is looking a little bit like urea. See this little pinwheel here with a few extra things. So I would probably put this in the urea-like category, which was type 3. Here's two glucoses attached together. So these are definitely type 2 molecules for sucrose. And the bicarbonate, tricky, looks like a pinwheel. So it looks like a type 3, but check out that charge. That charge makes it an ion. So this is actually a charged molecule and goes in type 1. So I'm hopeful that that maybe helps you. The entire purpose of the POGIL was to get you to think about what characteristics, what qualities in a molecule allow it to pass across the membrane easily with some difficulty or not at all. So keep in mind, small molecules move, non-polar molecules move. And so if we couple both of those together, we see something that moves across very, very, very fast. If you are small but polar, you're going to move. It's going to be a little bit slower. If you're big and polar, it's going to be really challenging. And if you are an ion, it's a no-go. You have to have a protein helper. So I'm hopeful that that helps you in processing the POGIL.